Good morning, everybody in China and everyone else. I'm happy to be able to come before you, give a seminar on Energy Internet platform for sensor-driven transactive energy applications. I'll explain all these terms as I go forward. So I'm with Virginia Tech. I've been here for many years. I was the president of the IEEE Power and Energy Society 2018-2019. And I go to China very often. I was in China many times last year, for example. So let's move on then, going forward. Next slide.
Yes.
So then the question is, what is the Energy Internet? So Internet is a network which allows information to flow from anywhere to anybody. Like you are sitting there, you can buy stuff on Amazon, transact on Alibaba. I can do other things with internet. That's internet. Like the internet, Energy Internet is a vast network that will allow efficient distribution of electricity to anyone from anywhere. You can buy electricity sitting in Beijing from South Africa, for example. This is the ultimate plan for Energy Internet. So I call this EI, stands for Energy Internet. It will use smart sensors, information communication technologies, ICT, and many algorithms we have to write to facilitate power supply in real time, enhance storage applications, and bring renewables into the grid. So three things: power supply in real time, storage, and integration of renewables in the grid will make the Energy Internet a good platform. Click one more. Okay, yeah, say that, good, thank you. So then we defined now in the previous slide what is Energy Internet. Now let me tell you what is the mission of Internet. What is the mission? What do you want to do with it? So as I said on the top line, Energy Internet is an online marketplace that transacts in energy. Like Alibaba.com can do trading anywhere in China and other countries as well. Amazon does the same thing. So I have three options here. O2O. Okay, now there are three levels: one-to-one, one-to-many, and many-to-one. For example, one-to-one, that means between individual users for bilateral transactions. Example, you go to Alibaba, one person has to sell a very special book, and you want that book. So you buy from that person. It's a one-to-one transaction, meaning that one person selling to you, one person, one-to-one. Next is one-to-many. In this example, one electric power company selling to many customers. For example, State Grid sells to 300 million customers in China. The third one is many-to-one. That means many customers sell to one electric utility. Example, you have in many homes in China, apartment buildings, rooftop solar. So those customers who have rooftop solar are selling electricity to one company, State Grid. That's many-to-one. That is the internet. Now, very careful, since we are talking about electricity, it cannot be time delay. It has to be done in real time. That means if you are selling power from rooftop solar to the power company, you have to sell it right now at the time you have the electricity being produced on your roof. Cannot wait. At the same time, all constraints must be met. For example, if you want to sell a lot of things from one warehouse to a city, you must be sure enough trucking capacity to carry those goods from the warehouse to the city. That means when you're talking about electricity, many buildings are trying to sell electricity in real time to the power company. We must make sure enough transmission distribution capacity exists in the network so that all that power from rooftop solar can flow back to the power company's network. Next slide. Yeah, very good. And now this is very important. If you look at this carefully, I call it vision for the future grid. The grid has three components. On the top, electricity transmission to transmit power. On the lower left, electricity production and storage. And on the lower right, electricity consumption. So let's look at the production storage first. Look at the storage battery. So first one on the left, lower left, electricity, production, and storage. We're using storage battery, rooftops, PV power, photovoltaics, hydropower, thermal power like coal, wind power, and nuclear power. At the top part, I have electricity transmission, which is transmission, substation, distribution. All of that is needed to bring the power from the source on the left to the demand on the right. And the lower right-hand side, I have electricity consumption. Buildings consume electricity, industries, factories, residences, even electric vehicles consume electricity. Those are the consuming parts. Now the three things. Transmission will bring power from the source to the load. Next slide, please. Okay, this is very interesting. If you look at this very carefully, a lot of information here. Mapping energy internet into the future grid. This is the objective. I'll just give you two examples. One is on the upper left, internet, a lot of storage and data handling capacity. And if you follow the green arrow going down, electric vehicles. Electric vehicles and charging station, the red line from left to right, charging station, and then an arrow going from the charging station to the transmission line, and from charging station, another arrow going to the smart network. So you'll notice in the middle of the picture here, I have the network transmission line. So that is the core of the network. Without transmission line, nothing happens. You can have a generation, you can have a load, they don't talk to each other. If you lose one generator, you can replace with a different generator. But if you lose the line, no backup, then the whole thing shuts down. Okay, so this is important. We have to have internet is like the transmission network, which makes everybody connected. And then we feed the supply to the network and receive current from the network to run your factory, like you see on the lower right-hand side, factory buildings, storage, all of that. So just to make sure we talk about the internet is like the transmission network. Okay, next slide, please. And this is the core of the discussion. A lot of things Chinese anyway can figure it out. On the left-hand side, we have the future power system. And on the right-hand side, I have the future power system integrated with modern information technology. So again, the core or the heart of the future internet, energy internet, is information technology, which connects everybody and we can talk to each other. Next slide, please. Very important. The future power system will have very special qualities. I call them pathway to energy internet. The 5 components, let me start at the lower left. Flexible, this white box with wheels. It has to be flexible and resilient. What does it mean by resilient? That means it can fail, but when it fails, it must come back to normal status very quickly. Next is open and sharing, very important. As you know, the Alibaba platform is open. Anybody can join, anybody can buy and sell things. And sharing meaning the Alibaba network allows people to share information about the things they are trying to sell. For example, I am selling a computer. What does it do? Its qualifications, its specifications, all of that is publicly available. That's what we mean by open and sharing. Then on the top, extensive and interconnected. That means extensive because it has to connect the whole world. Extensive. And every city, every village, anybody can buy from anybody else, and they must be all connected to the internet network to see what is available to buy and sell. Next, smart and interactive. That means if you go to this site, now energy internet, you must be able to see what kind of energy available for sale. Is wind power available? Solar power available, storage available, and you can buy, mix and match. I want to buy some solar, some wind, and some storage in my house. That's what I mean. Smart meaning it can figure out what kinds of resources are available to buy and sell. And finally, on the lower right-hand side, secure and controllable. Secure meaning if you place an order, the order cannot get lost on the way, or somebody cannot take your order and get it for themselves. That's security. Controllable meaning you want to buy so much power, but power is by definition instantaneous. It is in real time. But you should be able to control what you buy and how you use it. For example, if you agree to buy 5 kilowatts, their load in the house drops because your AC has turned off. You should be able to control what you buy and use only what you need in real time. Next slide, please. Yeah, click somewhere. That's good. Thank you. Now we defined them. We told them what they do. I'm repeating a little bit here. Functions of the internet. Okay. So on the left-hand side, I have 1 circle and 2 ovals. I define them as strong and smart grid. The strong grid is source, grid, storage, and load. Okay, and the lower oval is called ubiquitous, EIOT. Ubiquitous meaning it is everywhere, you don't realize it. It's ubiquitous. And EIOT stands for Energy Internet of Things. Then the intersection between strong and smart grid on the top and ubiquitous EIOT on the bottom, intersection is this oval called CPS, Cyber Physical System. Cyber Physical System.
Oh.
Then we have on the top the grid business, which is enterprise operation, grid operation, customer service. Okay, the new business in the lower half, you notice here is an energy service, buying and selling energy, not just from power station, could be solar, could be wind, could be storage, big data, PV cloud, charging station equipment, energy finance, electric vehicle internet, all of that is new business now. You notice at the bottom of the slide, I said source SGCC, State Grid Company of China. State Grid in China is a very strong supporter of energy internet. So I got the slide from a gentleman who gave a talk in Bangkok about a year ago now on a conference that we organized. So this is very much in line with what State Grid is thinking now to deploy the solutions in China at least. Next slide, please. Okay, we talk about the functions. Now, key technologies that are needed to run the energy internet. You see on the top, I show 3 blue boxes, which are the challenges I have to deal with.
最上面的3个蓝色的方框，主要是3个面临的挑战。
First is called holographic perception. Holography means it's a multi-dimensional view. I say holographic view means I can see from all directions. That means it has to be understood by many people with different perspectives. So then ubiquitous connectivity, that means everything must be connected, and the connection is almost automatic. If you think it should be there, it is there. You don't have to build it. It should be all interconnected. And the one on the right-hand side, integrated innovation. That means innovation will happen in many locations, but they must be all connected. So connect all of these blue boxes. I must have, number 1, intelligent sensor and terminals. Number 2, communication network and architecture. Number 3, IoT platform. And number 4, information security. Okay, again, this came from State Grid because they are planning to implement energy internet going forward. Okay, next slide, please. Okay, very important. I said it is not possible to have energy internet unless you have a functioning ICT framework. What is the framework? I give you 3 layers. On the top, called edge routers or wide area network. Then you have neighborhood area network, home area network. The home area network connects to the neighborhood network using smart meters. Next slide, please. Next one. Okay, so we give the idea now. I'm showing you how you will implement this in the real world. So you have on the top, smart switch, smart thermostat, other control devices for energy management system. And the communication system can be landline, can be radio, can be pager, can be internet, can be Wi-Fi, many different things. Okay, next page, please. Okay, now I'm defining transactive energy. Normally what happens, everybody in the system buys power from the power company. Fine. Right. I have here a buying and selling option. On the left-hand side, somebody wants to sell 6 kilowatt hour between 1 and 2 p.m. at 3 tokens per kilowatt hour, the selling price. For example, you got a selling number from 1 to 2 p.m., 3 tokens. The buying person says, I want to buy 5 kilowatt hour between same time, 1 to 2 p.m., and I am willing to pay 4 tokens, could be 4 RMB to buy this 5 kilowatt hour. Look at this. Buying is 5, selling is 6. That means there's more supply than the demand. That means it will be possible. Okay, so you see on the upper right-hand side, the yellow box says exchange of excess PV output. Okay, so that's the idea. We want to make sure there are enough sellers, enough buyers, and if there's more sellers than buyers in terms of energy, which is good, but then if more sellers come up, not enough buyer, so they might drop their price to make the sell possible. Good, so let's go to the next page, please. Okay, now I'm giving an example of how it is going to work. So there are 3 components here. At the bottom, you see WISE MRKT. That stands for WISE Market. On the top, I have WISE Building. I have WISE Grid. 3 things. I'll explain to you in a few minutes after Zejia finishes the translation. You saw on the previous slide that a market description. Somebody wants to buy at 6 RMB. Somebody wants to sell at 5 RMB. So buying price higher than selling price is okay. There is a market at the bottom, which is the gray box at the bottom. But how do I know how much I can buy, how much I can sell? This is a software platform that we built called WISE Building. They'll run a load forecast for your building. Also figure out, do you have rooftop solar? Do you have battery? Do you have load? All that calculation will happen to tell how much I want to buy, how much I want to sell. In the middle row, I have PV trading, DR trading, data analytics. That means this is the function, action. I can buy and sell PV. I can buy and sell. DR stands for demand response. I can cut down my load in the building and bring and buy less power. That means power company can sell that extra that I not use to somebody else. That's called DR trading. So at the bottom of the screen, you see source www.bemcontrols.com. That's a Virginia company who is doing this work. If you want to know more, go to the website, bemcontrols.com. They have a lot of examples of how it can be done. Next slide, please. Okay, now, a real-world example, transactive energy in a microgrid. What is a microgrid? It is a small part of the grid which is self-sufficient, meaning it can be disconnected from the main grid and still function. For example, if you focus on the lower part of the screen where it shows the microgrid, this is a real microgrid come from Chicago in the US. It has buildings, police buildings, hospital, library, doctor's office, solar PV, substations, and of course, connection to, on the top, other devices. So if you see on the upper half now, this TV screen, it goes to WISE Building, which is the energy internet platform. Then to the left is WISE Market, and further to the left is WISE Grid. They all connect to each other and make the transaction possible so that in this microgrid, somebody wants to sell, somebody wants to buy, somebody wants to store. All that is done by the WISE Market, WISE Grid, and the WISE Building platform. You'll notice this information also came from bemcontrols.com. So go to that website if you want and get more information. Next page, please. This is an example of rooftop solar. That's my building in Virginia. We have rooftop solar, so we can sell power to the building. The building doesn't need all this power. It can sell the power to the next building. That is called transactive energy. Next page. Okay, now, who are the participants in this plan? First is prosumer, P-R-O-S-U-M-E-R-S. That means producer and consumer. If you have a house, rooftop solar, you're producing electricity from rooftop solar, and the house also needs power at night from the power company. That's a consumer and producer together, we call prosumer. Other three parties are building owners, DER owner. DER means distributed energy resource, people who have a solar PV field, example. And then finally, DSO, distributed system operator, who is the power company utility keeping everybody connected. Next page, please. The more details about the transactions now. So you have on the left-hand side, same thing from the previous page, homeowners, rooftop solar. TE means transactive energy aggregator. What is meant by aggregator? This is a company who talks to many homes and collect information in real time. How much power house number one is selling, how much house number two is buying, how much house number three wants to sell. All that data is there. And they work with DSO, which is the distribution system operator, and they use blockchain network to keep track of the transactions. On the right-hand side, I have the microgrid, which is many homes in the microgrid. They are buying and selling from each other. I say transactive energy controller, and all the tracking of who buys at what price from whom is done using a blockchain network. Next slide, please. Okay, now what I mean by transactive controllers, the two kinds, active controllers and transactive controllers. Okay, the active controller is a customer who can adjust their energy consumption depending on price changes. For example, you have a dryer, clothes dryer, you have an oven, you have a water heater. All those can be used if price is high, low, a price high, you don't use them. That means you can adjust when to run the water heater, when to run the clothes dryer, when to run the air conditioner, depending on the price information. So that's active controller, meaning these are load people. The transactive controller deals with supply people. Okay, next page, please. And this slide shows application of a building automation platform, meaning each building you saw over there has this thing inside the building. Okay, if you see the right-hand side, I have the black and blue circle, HVAC, heating, ventilation, air conditioning load, lighting load, plug load, power meter, rooftop solar, and occupant comfort. All of these have to be done by the controller, with Wise Building Controller. And this is the Wise Building Cloud. That means all the information from the air conditioner, lighting load, plug load go into the account in the cloud in Wise Building. Could be hosted by Alibaba, for example. Next page, please. This shows an example of what I just talked about, real world example. Okay, you see on the left-hand side, I have a service provider, data, then residential gateway. This is important. The gateway is where all the data is stored. So then you have two lines. One is the red line, which is the network communication, and the green line is a power line connecting the battery, fuel cell at the bottom, air conditioner, water heater, refrigerator, dishwasher, and thermostats for the air conditioning control. Okay, then you have the red box on the upper side, energy management agent. The agent is a computer program watching everything, the dishwasher, refrigerator, water heater, fuel cell, battery, and make a decision which should run for how long to make sure the building owner pays the minimum cost for electricity. Next page. Okay, this is a summary. I have wise building, wise market, wise grid. All of those put together will give me the energy internet. Okay, so next slide. So this is my last slide. As you know, hopefully by now, I'm running for IEEE President-elect this year. Election will be held in August. So this is my website is www.srahma, and I have been the president of Power Energy Society. I was the board chair of the IEEE Publication Board. I have established PES University, also PES Chapters Council in China, India, Africa, Latin America. A lot of things have been done. I see Dr. Rumet in the audience today, so she knows quite a bit about this. So I am requesting you to be ready when the election starts in middle of August, which is about 2.5 months from now, and tell your friends to vote for me. If you want to know more about me, go to this website, srahman.org, and a lot more information there. Thank you very much. We can take some questions in the chat box.